Well, hi, I am Matías García. I'm going to present the compendium of all the key topics we have been discussing in the class of statistics of business. So, the collecting, the analyzing, and the interpreting of the data to drive the real world action after it. Um, for starters, the definition of strategy is an action plan requiring decision making based on the efficient use of available resources. So, action plans cannot rely on intuition alone. So, they must be carried out based on the reliable knowledge provided by rigorous data analysis. The three fundamental steps of this is first of all the collection of the data, and the processing of the data, the analysis, and the interpretation, so the meaning of this data. And there are two types of statistics. And the first one is the descriptive statistics, so mapping what is there in the data we have collected. And the inferential statistics are used to predict what is unknown based on the data we have collected. And categorizing the raw materials of evidence, so the population versus the sample. The population is the complete set of elements of interest, and the sample is a random subset representing the population. So is used when inferences are required to inferential statistics. And there are two types of variables: the qualitative, the non numerical attributes, and the quantitative, the numerical attributes. And in the quantitative variables are two types: the discrete, so the counted values with no continuity, for example, family members or gender or defective parts, and continuous variables and measured variables within an interval, for example, temperature, volume, or weight. Then, locating the center of gravity in your data. We can use three tools to do this. The most famous one is the mean, the average, so the exact center of gravity, highly sensitive, extreme, insignificant values can make the average unrepresentative, and the median, the middle ground, leaves 50% of data below and 50% above in an ordered set, unaffected by extreme layers and none like the mean. And the mode is the single most repeated value in a list of data. Then measuring the uncertainty of the spread of the data. So smaller dispersion means higher accuracy, and larger dispersions creates distance between data points, causing greater uncertainty and less precision, like we can see in the images. And the three concepts here important is the variance, so the average of the squared differences between each observation, and the mean is always positive, and the standard deviation and the most used metric, the positive square root of variance, returning the units back to the match to match the original data. And the coefficient of variation indicates how large the standard deviation is and relative to the mean, allows comparing dispersion between entirely different populations, other graphics, other sets of data. Then here we are entering here the topic of probability, the tool used to evaluate the reliability of conclusions when complete information is unavailable. And values range strictly between zero, so absolute certainty if it won't happen, and one, absolute certainty it will happen. We can see here the elementary set of theory and like the three concepts important here and their formulas, the writing of these concepts of probability. We can pass here to the two structural forms of probability: the binomial distribution, so the for example the coin flip, and the normal distribution, for example the bell curve. The bell curve is named the graphic here in this part, in the right part in the presentation. The binomial distribution, its nature is discrete, so used when counting specific events. For example, flipping a coin 10 times to calculate the likelihood of getting exactly 5 heads. And in the other hand, the normal distribution, its nature is continuous, so used for naturally occurring data, clustering around an average. So, for example, human height, most are average, while extremely tall or short individuals are rare outliers in the graphic, in the bell curve. And navigating the bell curve discussed, and two important concepts here. The C value, the standardizer, tells you exactly how many steps, so standard deviations, a data point is away from the mean. And the cumulative probability, while C value tells you where you are, cumulative probability tells you how much of the population is behind you. We can see here in the graphic the person here in the middle, in the right part or in the middle of the graphic. And then the balancing act of sample sizing. Again, three concepts here: the confidence level, written by a C, and usually 95%, and the C score of this value is written like 1.9596. The margin of error written by E, acceptable wiggle room, and the population standard deviation is the existing spread. We can see here in the image of the balance, the confidence level and the population standard deviation are on the left side. So more confidence or higher diversity requires a larger sample. We can see like the required sample size is in the right side of the image here, and the margin of error is like the base in the image, because demanding a tiny margin of error drastically inflates the required sample size. Then estimating truth within a margin of error. The logic of interval estimation is like the inferential analysis is the detective work of statistics. Instead of declaring a single vulnerable number, you provide a defensible range where you are reasonably sure the true population value lies. And we can see here in the image. So the sample statistic is in the middle, but we can take a margin of error and a confidence interval in is like the we like the safe zone of the of or value. And yeah, like the real world application here will be, for example, for the mean is estimating average. For example, the average barley life is between 10 and 12 hours, so the range we have been talking about. And for the proportion, is estimating percentages, not average. So between 40%, 45%, and 52% of voters support this candidate, for example. Then the court of data. We're finalizing here the hypothesis testing, the trial. So you start with the null hypothesis, assuming nothing has changed or there is no effect, and you only reject this hypothesis if your data is guilty beyond a reasonable doubt. We 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 will see an example. So there are two types of hypothesis testing: the one population and with two populations. With one population is testing a claim, and for testing averages, for finding averages, testing if cereal boxes, for example, actually weigh 500 grams as claimed, and for finding percentages, testing a company's claim that 90% of customers are satisfied. And on the other hand, with two populations, we are comparing groups, Group A and Group B. So for example, does a new medicine reduce recovery time compared to the old one? Or, for example, with percentages, do women click on an ad more frequently than men? This is the difference between one population and two populations. And the key concept here is the p value. So, if the p value is lower than 0.05, um, we can reject the null hypothesis, the first hypothesis. The research question, the research hypothesis, if it's lower, the p-value of the alternative hypothesis, if it's lower than 0.05, it's true, and the null hypothesis, it's not true anymore. So here we can see the conclusions um, of this presentation, and this is a complete cycle of statistical intelligence. It's important to know these concepts, these numbers, and the selection, the data gathering, the organization, the two types of analysis. It's important, but we must um, keep in hearts that after all these numbers, it's a human action. So a business action to benefit from all this data and analysis and statistics. This sixth concept, this sixth step, the strategic interpretation, translating mathematical significance into action plan. That's the importance of these lessons and topics. Thank you so much.